Welcome to all. Today's my topic is top-down parsing using LL1 parser. As we know that parsing is one type of LL1 parser is one type of parser, and this parser is used as to analyze the tokens in the programming language, and this parsing is basically a part of the compiler, and we know that compiler is a subject which compiles a set of tokens, and if we write a program in any programming languages, and then the corresponding high level language will be translated into equivalent machine level language. So, using the compiler, so compiler acts as an interpreter to interpret the high level language and to transform it into the machine level language, and a compiler cannot compile the whole program at once into the machine level language. So, it works in a number of phases, and typically in all compilers, so there are 6 phases starting from lexicon analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and the code generation. So, today we will now discuss only one parsing technique which is called the LL1. So, parsing is basically a part of the compiler, and as we know that in the parsing is basically to check whether a programming language is written as per the grammar of the production rules, and the parsing may be of two types, top down parser and the bottom up parser. Now come to the top down versus bottom up parsing. So, the top down, as the name suggests, top down parsing is basically parsing technique where the input string is generated from the start symbol of the grammar, and a grammar is basically the set of production rules from where we can generate a set of strings from the start symbol. So, in compiler we are basically analyzing the set of input strings, whether the input string is generated as per the grammar of the grammar prescribed by the production rule or not. In the top down parsing, basically we start from the start symbol of the grammar and eventually we generate the input string, while in the bottom up parsing it starts with the input string, and after replacing the input string with a top level non-terminals, and gradually the non-terminals, a set of terminals and non-terminals again converted to the top level non-terminal, and ultimately we will reach to the start symbol. So, one starts from the start symbol and eventually generates the input string, and another parsing technique which is bottom up, which starts from the input string and goes up to the start symbol. So, today we shall discuss only the top down parsing, and it's basically top down parsing may be of two types. So, recursively descent parsing means we start with the start symbol and we choose one of the production symbols, production rules, and if we found at any stage that one production rule cannot match with the input string, then what we do, we just backtrack to the earlier stage and try to explore with the other alternate production rules of the grammar, and we keep on going this production, choosing the production rules, and we will ultimately generate the input string. And so, as it uses the backtracking, so it is not the efficient technique, and it is time consuming and also consume the resources of your system. So, that is why you are going to the predictive parsing technique, which does not use the backtracking, and it predicts which symbol, which production rule to be chosen. So, before deriving the string, so but it needs a special type of grammar which is called the LL1 grammar. So, we will discuss also the what is the characteristics of the LL1 parser. So, now our topic is to discuss only the LL1 parsing, and before that let us show the recursive parsing technique, how it works. So, if we start with the grammar S produces ABC while B produces BC or B, and let us consider our input string is ABC. So if we start with the S symbol and choose the first production rule and we expand the syntax tree as A, B and C, now the B has two alternatives, either B, C or the B. So what to choose? If we choose the first production of the B, that is B and C, so BC, and ultimately the string will be generated as A, B, C and C, which does not match with your input. So that is why we have to backtrack. Okay, so we will backtrack from this stage to earlier stage. Now we have the another alternative of the B production. So B produces B. Now replace the B with the B. Now let us see what string is generated now, A, B and C. Now it exactly matches with your input string. So it's the recursive parsing technique and it uses the backtracking, so it's not efficient. So that is proved also. And now we are coming to the predictive parsing technique, and which also encompasses the LL1 parsing, and which needs the special form of the grammar, which is called the LL1 grammar. And grammar is said to be in LL1 satisfying the two properties. It does not have any left recursion and no left factors will be there. So a special form of recursion where A produces A and alpha, where you can immediately see the non-terminal in the right hand side. So this form is not allowed here. Another thing is left factoring. If S produces SA or SB or SC, so every time the S is seen in the right hand side alternative. So that type of form to be eliminated first, then we can convert the grammar into the LL1. Now, so we are moving to the LL1, how it works. So it is possible to build a non-recursive predictive parsing by maintaining a stack here, and here we are using one parsing table also, and along with it one stack is there and one input buffer is there. As you know that the input buffer is basically used to store the input symbols here, and the stack is used to use the grammatical symbols, terminal, non-terminals, and the parsing table is there, so which stores the rules while one non-terminal is encountered and one terminal symbol is encountered. What production rule we have to choose, that rule to be prescribed here, and based on that the parser will decide the particular production rules, and the sequence of productions will be generated by the LL1 parser. Now moving to the components of the LL1 parser. Input buffer, it stores the input symbols. The output is basically the sequence of production rules selected, and stack is used to store the grammatical symbols, and parsing table is basically a tabular form or the matrix form which has the two dimension. So the rows corresponds to the non-terminal while the columns corresponds to the terminal symbols, given a non-terminal and a terminal symbol in the column. So it specifies by the M, A and A. So it basically the rule while one non-terminal and one terminal A is encountered, which rule to be selected. Now coming to the parsing actions of the LL1 parser, how the LL1 parser works. So if we can consider the top symbol of the stack as the capital X, and the input symbol, current input symbol of your input buffer as the small a. Now based on the capital X and the small a, we have a number of actions here. If X and A both are $, that means it's a successful compilation of your program. And if it is a capital X and the A are the same terminal symbols, then what to do? The parser pops the capital X from the stack, and at the same time the cursor moves the right hand side one position in the input buffer, and the alternate decision is that if X is a non-terminal, now we have to look for the parsing table here. So let X is the non-terminal and A is the terminal symbols in your input buffer. So let us look at the cell X and A. So that gives basically the parsing action or the production rule. Let here production rule is there. So the X produces Y1, Y2 and Yk is prescribed into the cell of your matrix. Then what to do? We have to push the right hand side symbols of your production into the stack, but in the reverse order. Means if Yk appears last in your production rule, now the Yk will be pushed first and Y1 as the first symbol, which will be inserted into the stack at the last. Now for the other cases, means if X is not the non-terminal, A is not the terminal symbol, in alternate cases, now we will report the error. So let us explain this technique using an example. And so you are given the grammar here. S produces A, B produces BB and the epsilon. While the input symbol we want to check whether A is valid or not. So the work of the LL1 parser is to decide that A is correctly accepted or rejected. Okay, if it follows the syntax, if it follows the production rules, then we accept it, otherwise we reject it. Okay, so let us start with the stack with the dollar symbol and the start symbol of your grammar, and the input buffer is populated with your input, and one thing is appended, the hash dollar symbol is appended at the end of your, it is basically the end marker of your input. Now as per the production rule, S is the non-terminal and A is the terminal symbol. So what to do? Just look at in the parsing table, S row and the A column, we have the production rule already defined. So that is called the parsing table, and so we have to choose the rule. So the rule is that S produces A. So that time what to do? The S will be popped and in the reverse order A, B and A will be pushed into the stack. A is the pushed into the stack. Now let us look, match with the stack symbol and the input symbol A and A, both are the same. So that is why the A will be popped from the stack, and at the same time the buffer will be shifted in the left hand side so that we can process the next symbol B. So now B and B, so look at the parsing table B and B, we have the production rule B produces B. So this B will be popped in place of that. Now first B will be placed, B will be pushed and the next small b will be pushed. Now we have a match, now both are the terminal symbols B and B. So we will remove the symbol from the stack and we will shift the input buffer left hand side. Now this capital B and B, again we have the same production rules. So B will be popped in place of the B and B will be popped into the stack again as per this rule. Now these two are the terminal symbols B, so the B will be popped and at the same time the input buffer will be shifted, again the B and the small a. So for the table B and the small a, we have the rule B produces epsilon, so in place of the B we will replace it with the epsilon. Now we are left with the A, while in the input buffer A is there. So we are now have a match as per the rule number 1, both are the terminal symbols. So we will pop it, at the same time the input buffer will be shifted leftward. So now we have the match, so both are dollar at the same time. So we have the decision that the input string is generated correctly, so we will accept it. Now so what is the parsing tree? So basically the output of the parser, LL1 parser, is to draw the parsing table. So parsing table is basically the sequence of, so we have used the first rule, this one, we have choose the second rule, we have choose the third rule and the fourth rule, this one. Now if we draw the tree starting with the X, expanding A, B, A, now B is replaced by B and B, B will be again replaced by BB, now the capital B will be replaced by the epsilon. So this is the parsing tree generated by the LL1 parser. Now similarly we can go for the second example also. If you are given the grammar and if you are given the input string and the parsing table is given, now we have to, abiding by the rules of the LL1 parser, we have to verify whether the string is accepted or rejected. So initially the dollar is input into the stack and the start symbol of the grammar is the E and the input buffer is this one. Now as per the rule, thus the capital E and the ID, capital E and the ID, we have the rule capital E and the ID. So E produces T E prime. So E prime is pushed first and the T is pushed again. Now we have the match T and ID. So that time we can, if we check the table, we have the production rule this one. So this T will be popped and the T prime and F will be pushed here. So in this way, now if we got the F and the ID, so F and ID in the parsing table, we have the production rule F produces ID. So this now ID and ID are matching. So now ID will be popped, same time the input will be shifted leftward. Now T and plus, so T plus has one epsilon production here. So this T will be replaced by the epsilon here. Now E and plus has one production rule, produces plus T E prime. So plus T and E prime is pushed into the stack. Now again T and ID, we have the production rule, T prime will be pushed first, then the F, T prime and F and the ID. So this will be now replaced by ID, F will be replaced by ID, and then two are matching the same terminal symbols. So the ID will be popped and it will be shifted leftward. Now we are left with T and dollar. So we have the epsilon production here. So T will be replaced by epsilon. Again E produces E and the dollar. It has another epsilon production. E will be replaced by the epsilon. Now we are left with the dollar in the stack as well as in the input symbol. So as per the rule number 1 of your LL1 parsing actions, so we have to accept it. Now we are moving to the problem of constructing the LL1 parsing table. So before constructing, we should know the first and follow symbols of a terminal or the non-terminal of your production rules. So basically what is first? First of a terminal or the non-terminal is the set of strings, set of symbols which are generated by a string where the first symbols are seen. So a set of terminal symbols which occur as the first symbols of the string derived from the alpha, that is basically denoted by the first of alpha. Similarly, follow of A. So what type of what symbols follows A? That set of symbols which are following the A, that is denoted by the follow A. Now there are certain rules for computing the first of a string. If X is a terminal string, then the follow of the terminal string is the terminal string itself, and if it is a epsilon, then the follow of first of X is also the epsilon. And if we have a production rule X produces y1 y2 ... yn, now we have a number of symbols in the right hand side. We do not know whether y1 is null, whether y2 is null or not. So if we see y1 is null, then the first of X is nothing but the first of y2. If again y2 is null, the first of X is the nothing but the first symbol of the y3, and so on. So consider this example here. So the first, we can see that here the terminal symbols are generally the small letters plus, star, opening parenthesis, closing parenthesis, and the identifier, while the non-terminals are the capital letters E prime, T prime, and the F. So the first of all the terminal symbols are nothing but the terminal symbol itself. Now let us calculate the first of the non-terminal symbols. If you want to calculate the first of T, so okay, so for this one, the first production rule E produces T E prime. So first of E, as per the rule, we have to calculate first of T union of first of E prime. So if T derive epsilon, then this one, otherwise if T does not derive the epsilon, then the first of E is basically the first of T. So here the T does not derive the epsilon. We can see here the T does not derive the epsilon, we cannot see t derives the epsilon here. So the first of E is basically the first of t. Again, for calculating the first of E prime, we can see here first of E prime, the symbols generated by the terminal symbols generated by the E prime is the plus symbol here. Again, E produces the epsilon, so the first of E prime is equal to the plus and the epsilon. Similarly, the first of t is basically the first of f union first of t prime. If first of f generating epsilon or not, so here you can see the f does not generate the epsilon. So first of t is basically the first of f, and the first of f is basically the terminal symbols, the opening parenthesis and the id. Now let us calculate the first of t prime, which is the star and the epsilon, and first of f is the terminal symbols in the right hand side, the left hand parenthesis and the identifier. So now we should go for the follow calculation, which symbols follows a particular symbol, and that set is known as the follow set of a symbol. Now there are certain rules. If the S is a start symbol, then the follow of the start symbol is the dollar and if we have a production rule, A produces alpha, B, beta, and if we go for calculating the follow of B, observing the right hand side of your production rule, we can find that the beta follows the capital B, so follow of B will be the first of beta. So now, given the same grammar of which we have calculated the first symbols, now the follow of E prime, so first of all E is the start symbol, so as per the rules of the follow, if it is a start symbol, then the follow of E is the dollar itself, and if we want to calculate the follow of E prime, so we can see in the right hand side no symbol follows the E prime, so as per the rule, again the follow of E prime will be calculated as the follow of E again, which is the dollar. Now let us calculate the follow of T. Follow of T, so we can see in the right hand side follow of T the E prime, so first of E prime. Let us calculate the first of E prime. We know that first of E prime is the plus and the first of E prime is the dollar, but while calculating the follow of one symbol, the dollar will not be taken into consider. So this dollar will be, if we replace the dollar here, epsilon here, so the right hand side vanishes. So the follow of T is basically the follow of E again, which is the dollar symbol. So in this way we can calculate the follow symbols of all the non-terminals here. So now we have the summary table for the first and follow. Given the grammar, we have calculated the first of S and the first of follow of the S. Now let us move to the rule for constructing the LL1 parsing table. So just look in the, we have a production rule, A produces alpha. Now, so what is the first of alpha? First of right hand side, we have a set first of right hand side. Now for each terminal A in the first of alpha, so add this production to the AMA, where AM is the parsing table, A is the non-terminal which corresponds to the rows of your table, and A is the terminal symbol which corresponds to the column of your table. And now if epsilon is in the first of alpha, so that time we have to calculate the follow of the left hand side. This alpha has a left hand side A, so while the first of alpha includes the epsilon, then we go for the follow of left hand side, and for all symbols in the follow of A, we will include this production rule into the parsing table. This simple rule will be followed. Okay, say let us consider the first production rule, where into the table, parsing table, the first rule will be placed. So let us find the first of the right hand side. First of right hand side is the first of t, which we have already calculated the parenthesis and the id. So in the column parenthesis and the id, and in the row of E we have a entry. So E produces T E prime in the column left parenthesis and in the column id. Similarly, if we consider this one, E produces plus T E prime, we know that the first of right hand side is basically the plus. So in the plus column of your parsing table and the E row of your parsing table, the entry E produces plus T E prime will be inserted. In this way, let us consider the rule E produces epsilon. We know that first of right hand side is the epsilon, but will not be entered into the epsilon column. There is no epsilon column in the parsing table. So for that rule, we have to calculate the follow of E prime, which contains the dollar. Means in the E prime row and the dollar column, we have to include the E produces epsilon. So similarly, for the other production rules, we have to input this production rule into the particular entry of your parsing table. So in this way we have, so for the first rule we have calculated the right hand side of this one. We have seen left parenthesis is the first symbol, so and the id. So in the id column and the left parenthesis we have included this one. So similarly for the others also. Now the LL1 grammars. So we can see whether a grammar is LL1 or not, but just by observing the parsing table we can find that whether a grammar is LL1 or not. If we have more than one production rule in a particular cell of your parsing table, then we claim that this rule is not the, this grammar is not the LL1. Just have a look how we can decide that a grammar is not LL1. So given the grammar, we have generated the parsing table using the follow and first concept of your symbols. Now we can see that in the row E and the column E, we have two entries. E produces E capital S and the E produces epsilon. So as you have two production rules here, so given the E symbol and if one small e encountered in your input buffer, so the parser could not decide whether to choose the E produces S or E produces epsilon. So there is an ambiguity arises. So that is why this grammar is not LL1. Thank you.